study about the circular linked list. So these are the contents of our today lectures. We will learn introductions to circular list, creating the circular list, operation on the circular list, insertion at the first node, insertion at last node, insertion at a specific location, and deletion at first node, deletion at last node, deletion at a specific location, and traversing of circular linked list. Now, first we study what is the definition of a circular linked list. A circular linked list is a variation of the linked list in which the first element point to the last element and the last element point to the first element. So, a circular linked list is like as a linear linked list in which the last node next pointer points to the starting node. So, such type of link is known as a circular linked list. This is our example to describe a circular linked list. There are 4 nodes. This is the starting or first node. This first node point to the node B point to node C, and node C point to node D. D again point to the node A. So, we can say this linked list is known as a circular linked list. The circular linked list can be used to help the traverse the same list again and again if needed. A circular list is very similar to linear list, where in the circular list the pointer of the last node point not null but the first node. Now, how we create the circular linked list? So, that is the codings of denoting the node of a circular linked list. So, when we create the any node, we use basically the structure, and we create a struct node, and we know that a node is basically consist of 2 parts. First one is data and second one is the next. Next is a pointer that is used to connect the next node. And we use a start pointer. This start pointer in the circular linked list always denote the first node, and when we declare this start node before creating the node, we always set start pointer to null. Now, we learn the algorithm to creating a circular linked list. First, we have to create a new node that is denoted by the pointer also ND, and when we create the new node, we always set the new node data to a element or item. If start pointer denote the null, it means there is no any node in the circular linked list. So, we firstly set start pointer to the new created node ND, and we use the pointer variable that is used to process the all elements or nodes of a circular linked list, and as we start or create the first node, then we always set this PTR to the new created node. If our circular linked list is not empty, it means that elements is already exist, then in such case we basically proceed each element using the pointer variable. PTR next is assigned to new created node, and new created node pointer is set with PTR, and new created nodes data is set with item, and next part or next pointer of new created node is set with start. Now, there are some operations which are generally performed on a circular linked list. So, there are insertion operation. So insertion operations are basically performed in three ways. First, insertion at the first node, insertion at the last node, or insertion at a specific location. So there are three ways for performing the insertion operation. Now, how we perform the insertion operations? To understand this problem, we consider this diagram. This denotes a circular linked list because in this list we notice that last node point to the first node, so it create a circle. Now, in this node, we basically want to insert a new created node P at the starting node of a circular linked list. So, to perform this, first we have to set the start, we have to add this node at the starting node of circular linked list. So, we basically point the last node to new created node and next portion of the new created node is set with the start pointer, and start pointer is again set with the new created node. So, that is the mechanism of adding or inserting a new node at the first node of existing circular linked list. Here we mention some codes, or we also can say some algorithm steps for adding a new node at the first or beginnings of circular link. We use a add first procedure. First, we create a pointer t, or it is some also known as a PTR pointer also, and we set this pointer with the starting pointer. The starting pointer is basically used to point the first node of a circular linked list. After that, we create a new node using the pointer nd, and using this statement we create a new node. When we create this new node, we put the item in the data portion or information portion section of node, and after that we try to add the new node at the starting of the circular linked list. First, we have to check that the circular linked list in which we want to insert the new node is empty or not. For this, we use the statement mentioned here. If the start equals to null, it means, or if our start pointer denote the null value, in such a case it means there is no any node in the circular linked list. So, we have to create first node. In such case, first we set the start pointer to the new created node. It means this start pointer will first denote the new created node, and next pointer of the start is moved at the next of start. Else, it means there is some data in the circular linked list. In such case, new node next is set with the start pointer, and after setting that we move to the first node. So, we move the first node, we first use the while loop statement. PTR next is not equals to the start. In such case, we procedure PTR equals to PTR of next, or in other words, we also PTR denote the pointer denoted the T. So, we can say PTR is basically go next of PTR, it means it is jumping to the next nodes, and after that PTR next is set with the new node, and start pointer is back set on the new node. So, that is the algorithm of adding or inserting a node at the beginnings of a circular linked list or the first node of a circular linked list. Now, our next operation is the insertion at the last. In this operation, we basically create a new node, and this new node, created new node, is basically add at the last node of an existing circular linked list. Now, in this diagram, we can consider here we create a new node P which data portion is 50 and its next pointer is null. Now, we want to insert this new node at this last node of a circular linked list. So, to perform this, we first add the next pointer of the last node to the new created node, and next pointer of new created node is pointed to the first node. So, that is the mechanism of adding the new created node at the last node of the circular linked list. Now, here the algorithm steps of how we basically insert a new created node at the last of a existing circular linked list. We made a procedure at last and we create a pointer PTR or T. T or PTR basically set with the start pointer. This start pointer is used to denote the first node or starting node, and after that we create a new node using the pointer ND, and when we create new node we assign data in this new node, and after that first we check our existing circular linked list is empty or not. So, we apply the condition here. If start equals to null, then it means there is no any node in the circular linked list. So, in such case we first set the start pointer to the new created node and start of next of start is set to start. Else it means there is no empty, it means there are some data. In such case, basically new created node's next pointer is set with start, and after that we go to the last node using this condition. While PTR is not equals to null, then we move the PTR pointer to the PTR next, and PTR next is set with the ND, and start pointer is back go the new created node. Start is set with the ND. Now, next operation is insertion a node at a specific location. Suppose this is our circular linked list and we want to insert a new node having the element 30 after the node 2 and before the node 3. So, to perform this operation we basically use the same algorithm as we have read in the singly linked list. So, to perform the insertion at a specific location we use this algorithm we call insert SPR not procedure, and we create these types of the pointers. First we have to recognize that in which position or which location we want to insert the new created node. So, we will take a int pos variable and first we create the new created node. After creating this node, we first set the next pointer of new created node with null, and after this first we check the empty condition of the circular linked list. If our start equals to null, then in such case we basically set the start with new created node, and we also set a new pointer ptr with the new created. Else it means some nodes are already exist in the circular linked list, then we set ptr to the start, and start basically denote the starting node of a circular linked list or first node of a circular linked list, and after that we find the positions where we want to insert the new created node. So we apply this statement. Now after that ptr is set with ptr next. It means ptr go to the one by one step forward, and when we get the proper position, then ptr2 is set with the ptr1's next, and ptr1 next is set with nd, and nd next is set with the ptr. So that is the algorithm of inserting a node at a specific location. Next operation is the deletion operation, and deletion operation is also performed in the three way. First, deleting a node at the beginning of existing circular linked list. Second, deleting a node at the last end of the circular linked list, and next is deleting a node at the specific location of a circular linked list. So this diagram denotes how we remove or delete the first node from existing circular linked list. So this denotes the circular linked list. Here start denote the first node, and this is node A, B, C and D. So our aim is to remove or delete the node A from this circular linked list. So when we will remove this node, our star pointer will go here, and next pointer of last node will denote the second node. It means will point to the node B, and after performing this we can free the node A from the memory. So that is the mechanism of removing or deleting first node from the circular linked list. So in this procedure we consider in a algorithm for deleting the first node. So to perform this we use a procedure void delete first. First we create a ptr pointer or t pointer. T pointer is also here can denoted like as a ptr pointer. So t is set with the start. Now if we check again condition for the null, if the start equals to null, it means there is no any node, and if there is no any node, then we can say our list is empty. Else if our list is not empty, then we can perform start is set, start next is equals to start, and we free the t, and start is set with null. Now next condition is that if start next is not start, then in such case we basically set t is set with t next, and start is set with start next, and after that we basically free the next of t, next of the ptr, and next of the ptr is set with the star. So that is the algorithm that denote how we remove the element from the first node of a circular linked list. Second operation is deleting a node from the last of a circular linked list. So this node denote this set of nodes denote a circular linked list, and this is the last node which we want to remove it. So to remove this node, we basically set the next pointer of the second last to the first, or we can say the second last next pointer is set to point the node A or the node first. So using this procedure, we can perform the deletion of the last node. Now, these are the algorithm how we delete the last node. So, first we set node T or node PTR to star. Here pointer T is also known as PTR. In some steps we use the PTR replacing the T. So, we also can say T is as a PTR. Now, if start equals to null, then we can say our list is empty. Else, if start next equals to start, then in such a case we can say there is a one node, and this one node can remove free T, and start is set with null. So it denote in the case where there is only one node in the circular linked list. Now, if there are more than one node in this condition, we basically use the while loop. While T next of T next of T is not equals to start. In this case, we basically set T equals to T next, and we free the T next, and T next is set with the start. So that is the algorithm of removing the last node from the circular linked list. Next algorithm is how we remove the node from a specific location. So in this case, we can use the algorithm used in a single linked list. The same procedure is applied here. So here we use some pointers, and they denote the new created node pointer, and PTR process the elements of circular linked list one by one. PTR1 and PTR2s are those such type of the pointers which denote the value. PTR denote the position where we have to insert, and PTR2 denote the positions before we have to insert, and temp is used a pointer that hold the node to be removed from the existing circular linked list. Now here we use the pose variable. This pose variable was basically used to denote from which position or which location we want to remove the node. Now first we check for empty. If start equals to null, then we can say our linked list, circular linked list is empty, and if our circular linked list is empty, then we cannot perform the deletion operation. Else, it means there are some nodes in the circular linked list. In such case, first we use PTR1 to set the start node, and using this we apply a for loop to reach the element node to be removed. So using the pose minus ones denote the one position before the node to be removed, and PTR ones is set with PTR next. It means PTR is go one by one forward, and after that we get the required node, and required node is set with the temp pointer, and setting the required node in the temp pointer, we set PTR next equals to temp next. It means the variable that is just before the node to be removed is adjusted or linked with the next node of the node to be removed, and after that we basically free the temp. Now next our operation is the traversing operation. What is the traversing operation? Basically, traversing operation is accessing each element one by one and displaying them is known as a traversing. So, how we traverse a circular linked list, and in other words we also can say how we display the contents of a circular linked list. So, to traverse a circular linked list we use the following algorithm. We basically use traverse procedure, and we create a pointer T or PTR, and we first basically set the PTR or T to the start. It means basically set T at the starting node. If our start is not start equals to null, in this case our list is empty, and in such situation we have to return from here. If our node is circular linked list is or not empty, then in such cases we basically use the while loop. PTR next is not start, then we basically access one by one node of a circular linked list. So we basically display the T data, it means information sections of the node, and T is moved forward, T equals to T next. So, using this procedure we can access all the elements of the circular linked list, or in other words all nodes of a circular linked list we can display. So, our today lecture are here. Thanks.